All right. Again, my name is Mike Pissarro. I'm the Policy Director. I have the great pleasure of having two individuals from New Jersey American Water to talk to us about drinking water, from source to tap, the story of drinking water. We are recording this webinar. We will be sending out a link to the recording following this session, probably in a few days, and it will be available on our YouTube channel in the future. If you have a question, please use the Q&A feature on Zoom. It is usually on the bottom of the screen. We will be monitoring those questions. I will mostly be holding those questions until the end of the session. But if there is something I see that needs clarification, I may jump in and ask that question. Everyone, I greatly appreciate you taking a Wednesday evening, a beautiful Wednesday evening, to learn more about drinking water. So before we get started, do have a land acknowledgement. So we recognize that the land and water now under our care is the traditional and ancestral territory of the Lenape. We pay respect to the Lenape peoples, past, present, and future, and their continuing presence in the homeland and throughout the Lenape diaspora. We respect their knowledge, culture, and tradition, which have contributed to the conservation of land and water. All right. If this is one of the first times you have joined our webinar series, this is a Watershed Wednesday webinar for the Watershed Institute. Our mission is keeping water clean, safe, and healthy. We work to protect and restore our water. Oops, I hit advance way too soon. Water and natural environment in central New Jersey through conservation, advocacy, science, and education. And we administer several statewide programs. We have various strategies we use to protect and enhance our water, and one of them is scientific investigation and monitoring, including Stream Watch. Advocacy, which I'm particularly interested in, being the advocacy director. We protect and restore our water and watersheds. We have environmental education and modeling best practices at our watershed center and 950-acre reserve. So we have green infrastructure, we have a green roof, rain gardens, porous pavement, we have a cistern, solar panels. We have quite a few practices. So if you've not been out, come out and take a look at it. We have, as I mentioned, this is our Watershed Wednesday, which is usually every other month on Wednesday, the third Wednesday of the month, and it is general topics of interest of the community. We have a technical Friday on Fridays. So with that, I would like to welcome Cassandra Malone and Danielle Kersley of New Jersey American Water. I'm going to kick it off to Cassandra. If you could just do a brief introduction of both yourself and Danielle, if you could, and then you can share your screen and we can go forward with the program. Again, thank you, and off to you.
And thanks so much, Michael, and a big thank you to you and the Watershed Institute for giving us the opportunity to share our story. My name is Cassandra Malone. I'm currently an environmental program lead with Corporate American Water. Previously, I served as the manager of water quality and environmental compliance for our central operations region in New Jersey, which serves this area. I started my career in 2008 as a laboratory technician, working for a small company that offered laboratory and contract operation services. Went over to New Jersey American Water as a laboratory supervisor in 2017. Went to college, graduated in 2006 with a degree in environmental science. I went to college thinking I could be a Planeteer. I'm kind of dating myself because I'm a kid of the 80s and grew up watching Captain Planet. And if you're not familiar, he was a superhero with, and I won't sing the theme song because I don't have quite a nice voice, but I really thought I could learn how to save the planet by studying environmental science. And really what I learned when I went to college is that humans really aren't so nice to their environment and everything gives you cancer. So a little bleak outlook upon graduation, but as soon as I entered the workforce and started working for water, I realized how passionate I was about protecting this natural resource, and working for New Jersey American Water has really given me the opportunity to do good and, fulfill my dreams of being a planeteer as a child. And with that, I'll have Danielle introduce herself.
Good evening, everyone. I am Danielle Kearsley. I'm environmental program lead for New Jersey American Water, and my territory is Central and North Jersey. I went to college for environmental sciences, just like Cassandra, and started my career in environmental consulting in the mid 90s. Worked on a lot of tank yanks. Did just a lot of yucky remediation projects, and then followed up with another consulting company and did a lot of industrial site remediation projects. Most of my career was spent, cleaning up messes and working for polluters. So it was, kind of, felt like you were doing a good thing, but I was very happy in 2019. I switched over to New Jersey American Water, and I was like the client now, no more timesheets. If anybody consults, that's a big, big plus. And now I get to work for a company whose product is clean water. So, can't get better than that for an environmentalist to, work for a company that's main focus is clean water. That's their product. So I'm happy to be here, and I'll send it back to Cassandra. You're there, Cassandra. Yep.
Yay, thank you. It's so nice when it actually works. Right, so we are here to tell the story of drinking water from source to tap. Thanks again for having us. It's just a little bit about New Jersey American Water and what we do. Well, American Water to start with, since they're our parent company, but American Water has served customers in communities for more than 135 years. We are the largest publicly traded water and wastewater utility company, and we cover a lot of ground across the country. Our size and scale definitely differentiates us from our competitors, and we are really dedicated to our communities, as you'll see as we go through these slides. So this is our footprint across the country, and you'll see we've got our biggest presence is typically in New Jersey and Pennsylvania, but we do have other areas in the country that we serve, approximately 14 million people in 24 states. So that's a lot of drinking water we put out the door. So manage across the country, there are about 500 regulated like water and wastewater systems that we're in charge of. We also have our military services group where we do contract water system operations and wastewater system operations at military bases. But you could see here our inventory of systems. That's 52,500 miles of transmission, distribution, collection pipes, and mains in the ground. So that's quite a large amount of hardware down there that you don't really see. We've also got 80 surface water treatment plants, 480 groundwater treatment plants, 1,100 groundwater wells, and 160 wastewater treatment plants. A little bit about New Jersey American Water now, close to home. I'm a native of Pennsylvania, but I consider myself fully Jerseyfied at this point. But we've got about 850 employees in the state and serving approximately 2.8 million people over 18 different counties throughout the state. And that's a lot of customers. So a little bit about our infrastructure, and we'll tie this all together when we proceed to the next slides, but about 74% is our surface water. So we're really dedicated to source water protection, and we really recognize the importance of that, and so appreciate the work that groups like the Watershed Institute does, and folks like you take an interest. Just by seeing the volume of people on this call is just absolutely tremendous. We've got, throughout the state, we've got 7 different surface water treatment plants, 5 of which have director's awards for the Partnership for Safe Drinking Water. We're held to a different standard for certain parameters, and we do a very good job of that. And, the amount of pipe in the ground, you really got to consider that. We've got about close to 10,000 miles of water and sewer pipe in the ground. And, we don't really appreciate how critical that is to our safe water delivery at times. Communities in the following counties that we serve. So close to home. I know I would assume that, a large number of participants on this call are our customers. So really grateful for the opportunity to interface with you on this. Wastewater systems scattered across the state. We're expanding our footprint in wastewater. And, you'll see the need for this as, we get into the slides and we get the idea of the state of the infrastructure in this country. Drinking water's got a C- across the country, and this isn't for specifically New Jersey American Water. This is across the country, every single utility. So we need some investment, clearly. So we've improved in the past, but there's still a lot of work to do. Regulations like the Water Quality Accountability Act hold water purveyors to certain capital investments and improvements in the system. So a lot of the way that the water system, our current infrastructure state, is due to lack of investment in those things. That money gets spent elsewhere and we haven't been keeping up. So a lot of our pipes in the ground are failing and we just can't see it. And we're making investments throughout the state. And what our cost model is, we spread the cost out. So not one single community is overburdened when they need significant capital investment to ensure safe drinking water deliverability. That's how many miles of pipes we've replaced since 2010, which is pretty extraordinary. It's, you see guys out, when something's buried, an asset is buried, it's very difficult to get at. So I think you can kind of appreciate the scope of replacing that much linear feet of pipe over such a small period of time. We also we say we're customer obsessed. We want you to be happy. We want our customers to feel safe when they open that tap to take a drinking water, shower, to cook. So, we have 24/7 customer service available to report for emergencies. If you're out of water, if you're experiencing discolored water, you can call our center and we'll get you connected to the right people. We also have an emergency alert notification system. If you are not signed up for this, I highly recommend you do so. This will give you real-time text messages, emails, phone calls when there is something going on, things like hydrant flushing in our system, which we do routinely on an annual basis. You'd receive a notification of that, and any other work going on in your area that could potentially disrupt the clean water coming to your homes. Particularly sediments can get stirred up when we do work in our distribution system. We also have a new mobile-friendly website that you can access, and it's more of a self-serve at this point. So highly recommend that everyone check that out, and you can put your information in there. We're also committed to paperless billing. A lot of paper waste gets generated this way, so I'm glad that our company recognizes that the need to go paperless. We also have a customer assistance program, H2O to Help Others program. There's grants up to $500, and there's a service charge discount for people who qualify. We're also very heavily involved in our communities, and I'll stop speaking and allow Danielle to speak to some of the activities we purvey in our communities.
Sorry. Hi. So in New Jersey, we have an environmental grant program. We usually push that out in January of each year, and we collect applications through the end of March. The environmental grant program is for any type of watershed projects. We are solely trying to improve source water. So that is our focus, and we welcome grants and choose grants that are focused on our watersheds and also our source water protection. We usually choose approximately 4 grants that we give out every year. We try to span those over the state. So we get all our regions in the north, central, south, and coastal. In addition to the New Jersey American Water grant, there are other grant programs that that we offer. There's the Protect Our Watersheds art contest. We have a firefighting support grant program, which is fantastic. Our local emergency personnel, you know, are just, you know, whatever we can give back to them, we try to do. We also do plant tours, school visits, open houses, you know, any type of community charitable support. We're helping plant some trees along a brook in Manville next month. We have a lot of stewardship activities. We participated in Raritan Headwaters stream cleanup last week. You know, just we try to really get out there with the community and volunteer as much as we can. There's and then also there's corporate grants available as well, corporate environmental grants. So for any further information on these, just definitely visit our website, and under the community tab, there's the list when we collect the applications and the criteria for our applications. Thank you.
Thank you so much, Danielle. Danielle does lead the charge on environmental grant program awards up to what, $10,000?
$10,000. Yep. And I lead the one for the grant program for New Jersey. So we're in the process now of reviewing all our applications.
And what's the deadline for that?
The deadline was March 31st, and
Okay.
we should be, you know, reaching out to those who applied in the next couple of weeks.
Awesome. Thank you, Danielle. So getting into the fun part, what you're all here for, the story of water. So an introduction to a water utility. We have three main jobs. First is to manage the water. It's found in our lakes, rivers, and other places, groundwater. We treat and clean the water, disinfected so that it's safe for public use. And we also are tasked with getting the water to your tap. So we talked about infrastructure like pipes in the ground. There's pumping systems available. It's a lot that goes into getting that water to your tap. But our objective is to get clean water to everyone that we serve. First job, and just like we all partner with the Watershed Institute on and lots of other organizations throughout the state. But we need to oversee water and nature and kind of have an idea of what water quality we're receiving into our plants and do what we can to ensure that that water quality is as good as possible before it enters our plants. Source water is typically either surface water or groundwater. I'm not going to get too much into groundwater today since we're watershed focused here, but it's below the lower surface. It requires some pumping, electrical to get it out of the ground, but surface water is a little bit easier to get at, doesn't require as much pumping depending on your source, but it's anything found above the earth's surface. So we're talking lakes, rivers, reservoirs. Ocean water can technically be used as a drinking water source, but it's really not economically feasible because it takes so much power to clean that water up and make it potable. So it's not really prevalently used. So source water is unsafe to drink. Groundwater, not so much, but you wouldn't want to go stick a straw in the stream right here because you'd potentially get sick. There are pathogenic organisms that exist in these waters. They're naturally occurring, but they're very harmful to your health. So that's why treating and cleaning up the drinking water and disinfecting it is so critical. So how does source water get to the utility? Well, use a lot of pumps, very high powered pumps to move the water from our intakes and into the plant throughout the plant. We also have gravity options, like a waterfall here. If we're located downgrade, we also have the opportunity to use gravity to get the water into our intakes. Our second job is to treat and to clean the water. Our source water is cleaned. We remove sediments, organic matter, all those colloidal materials that make water our source water kind of unpalatable to look at, we take all of that out through our process. So it becomes, when it becomes treated, it's considered potable and safe to drink. So that's our little industry jargon for drinking water is potable water. So utilities can clean and disinfect water through a variety of processes, and we'll get into that a little bit later. Our third and final job is to deliver that water to your tap. So water moves through a series of pipes. They're interconnected. We have booster stations, and booster stations are those, and you've probably seen them driven by one every single day and not even realized it. They kind of look like little shacks that are fenced in, but typically they're very large pumps that we need to move water up hills into higher pressure areas and get the water to where it needs to go. Our infrastructure handles about 40 billion gallons per day, which is pretty amazing. Our final and third job, oh, well, that's that. I realize these are really lovely animations we have here. So this is a really great diagram of all the components that make up a water system. So we'll go through this diagram kind of step by step, but in this picture, both 1A and 1B are two examples of options for our source water. We can either have a reservoir or a lake, or we can pull directly from the river. Both of these sources have their challenges for treatment. Run-of-the-river plants and surface water in particular, like I said, is very susceptible to pathogenic organism presence. So we have to treat for that. It's also more vulnerable to things like spills or contamination events. There's things that we can't control, like transportation issues. I'm sure everyone's heard about the awful environmental disaster in Ohio a few weeks ago. So we are aware of all of our railroad crossings, and we work very closely with our local OEMs and the New Jersey Water Supply Authority for information about any spills that occur so that we can take action, before it gets to our intakes. Surface water is a little bit different than groundwater to treat. Groundwater typically holds kind of more contamination, like volatile organic compounds, PFAS. I'm sure everyone's heard of PFAS at this point, polyfluorinated compounds, which are forever chemicals, and they exist in our groundwater sources in a number of places. So a little bit, different types of contamination or parameters that we might see depending on the source. So the first step is to pump the water into the plant. So you can see the arrow indicating that the water is entering the plant at this point. We would typically, our first step in the treatment process is very simple. It's a physical removal of any twigs, branches that are coming through our intakes. We use screens, bar racks, things like that. From there, we look to a chemical addition to help clean the water. We typically use something called a pre-oxidant, which takes care of organic matter in the source water. Some different types of pre-oxidants that can be used are ozone and potassium permanganate. So that's what we use at our treatment plants in central operating region in New Jersey. This is the water that you're receiving. So we actually have two surface water treatment plants in our central operating region, both the Raritan Millstone Water Treatment Plant, which pulls from the Raritan River, Millstone River, and the DNR Canal, depending on the time of year and availability of supply. Our Canal Road Water Treatment Plant also pulls from those sources as well. So let me go back a slide if I can. So some other treatment processes that are important is, once we go through the pre-oxidation phase, our step of treatment, our next step is to drop the colloidal material, or those fine, when I say colloidal, I mean finely suspended particles that are difficult to remove. They don't have very good settling rates. They'll tend to stay suspended and, make the water dirty appearing. The other thing is those colloidal materials can mask pathogenic organisms. So it's really important to take that out through the cleaning process. So what we do is add a coagulant. In particular, we add aluminum sulfate. There are other coagulants out there that work just as well, but it depends on your source water quality constituents. But coagulation creates floc, which then travels through our sedimentation basins. It takes about 4 hours for water to pass through our sedimentation basins, but it's a baffled structure, deep basin where as water flows through the basin, it's dropping out that particulate matter, making it safe. We also add chlorine in our basins as a measure of disinfection. We need to meet a certain level of disinfection as a surface water treatment plant. We're required to maintain 99.99% log removal of pathogenic organisms, which we consider 4 log removals. So that's what we look at. After going through the basins, disinfection, settling, waters pass through filters. The Raritan Millstone plant can do up to 180 million gallons per day. We have 36 filters at that location. And so those filters kind of act as a artificial earth, so to speak, kind of mimicking the groundwater process where I know if you're a person that's on your own well, or you're a customer of ours that's getting primarily surface water, you notice very different tastes in these things. And that's because of the treatment process that it goes through. So once water leaves our filters, there's additional chlorine added and our plant is actually a chloraminated plant where we're doing a combined disinfectant residual. It's a combination of chlorine and ammonia. This is to allow the disinfectant to persist in further away from the plant that it goes. And it also minimizes the formation of something called disinfection byproducts, which include a class of materials called trihalomethanes and haloacetic acids. Those are the nasty carcinogenic compounds where longer term exposure can cause potential health effects. So that's why we opt to use chloramination as our primary disinfectant. We also add phosphate as a corrosion control inhibitor. And what that does is it bonds to the inside of the pipes to avoid any leaching out of materials, particularly lead and copper. Lead's been in the news a lot. So we've been effectively practicing corrosion control since 1994. So we've got a really great coating of phosphate on that pipe. And so we're in compliance with the lead and copper rule as it stands. Our Raritan Millstone plant also has the ability to add fluoride. That's an additive. It's recommended by the American Dental Association. And basically once that goes in, you can't take it out. Hydrofluoric acid is not particularly safe to work with. And, it can kind of, there's a lot of chemical storage requirements that come through this. And we also have continuous online instrumentation. So we ensure that we're not overdosing on that particular chemical. So once the water leaves the plant, it is pumped out into the distribution system using very high level or high capacity pumps, in addition to those pumps that are already in the distribution system. But the water gets into your pipes, it's going into the storage tanks. And what storage tanks do are basically a buffer for us. Pressure-wise throughout the system, we can ensure that large quantities of water are available and can meet system demand. And you'll notice, especially we had a very hot, dry summer last year, and that was we can be a little not challenged keeping up with system demand, but it is a concern of ours. So you might notice during the summer months there are water use restrictions because the idea is that we want to keep water in the pipes for firefighting and sanitary reasons. That's a really important component of this, as well as the hydrants and the fire protection that our water provides. Now we talked about distribution mains. There's also another component to distribution mains, which is your service line. This is the piece of pipe that connects the large distribution or transmission main to your house. So service line's job is to carry the drinking water from the main into the plumbing of the building. And easy peasy, and once it's installed, you just turn the faucet on and voila, you've got water. Some interesting part about ownership of service lines, and I bring this up because the new lead service line replacement rules that were passed in New Jersey recently. The water system technically owns the water service up until the curb stop. From there, it's the customer has ownership of that service line. But we are working with our communities and our people to have our customers identify their side of the service line materials. Because if you've got lead or galvanized piping, we're going to want to get in there and replace that. And I can't say it'll be, tomorrow, but we need to have an inventory, an accurate inventory to know where we need to target to meet the lead service line replacement rule requirements. So there is a portal. If you go onto our website, you are able to self-identify. And there's a lot of really great information on how to identify your piping, particularly if it's lead. You're going to notice it's got a dull gray color, and scratching it with a point or something is going to leave a mark. So that's your indicator that it is lead. So I get this question a lot, is my water safe to drink? And I can always say that water meets primary drinking water standards. We test for a lot of different things. And coming back from my previous days from New Jersey American Water, when I used to work at a laboratory, we'd have people ask, can I just do a poison water test? There's no such thing. There's parameters that we look at for potability and drinkability, and that's what we go with. So every treatment process is designed to maintain compliance with these primary and secondary drinking water parameters. Now, primary standards all have a maximum contaminant level. This is the maximum permissible level before it has an effect on human health. It's enforced for municipal systems. And when I say municipal systems, I mean community water systems like ours. They're also enforced for something called non-transient, non-community water systems. For instance, if there's a school that's on its own well or an office building that's got its own well, they're treated just about the same as we are, maybe a little less stringent. But just so you know that they are being tested, and the government didn't forget about them. So these particular our primary standards include very specific chemicals and pesticides and over 80 different contaminants, including lead, copper, arsenic, nitrate, nitrites, cadmium, chromium, nickel. There's all sorts of things out there that we can test for. A big thing that we also look at is volatile organic compounds. This is a scan of quite a number of different compounds that are carcinogenic, things like tetrachloroethane and so on and so forth. And obviously PFAS, we look at that as well. So of these primary standards, most of these are a concern with long-term exposure. The two exceptions to that, and we call them acute parameters, are total coliform and E. coli and nitrate. So nitrate levels above 10 parts per million have the potential to cause issues for pregnant women and babies. Can give newborns blue baby syndrome at levels above that. So these are things that can immediately make you ill, as opposed to long-term or chronic exposure. Same thing with coliform and E. coli. This is why we disinfect our water. We want to ensure that these organisms aren't detectable in our leaving the plant and in our distribution systems. And in fact, our Raritan system, because of the size of our system, we're required to monitor pretty much continuously throughout the month. We have to take 240 routine coliform samples, which test for total coliform and E. coli every single month. So that's a lot of testing that we're out there doing just in our system. And we use representative locations to monitor. But total coliform, is it something that's considered an indicator organism? On its own, it's not going to make you sick, but it's the indicator for the potential of contamination of E. coli. And these things are typically tested for simultaneously when we do our analysis. Now, moving on to secondary standards, these are things that are not going, levels above the recommended upper limit or recommended maximum contaminant level. Just a little industry jargon. They cause aesthetic problems, things like staining, taste and odor issues. Many are naturally occurring. Things like hardness is not actually a contaminant, rather water quality characteristic. That's pretty important when it comes to corrosion. Same thing with alkalinity. We talk about that a lot. pH is a secondary contaminant or parameter. I hate using the word contaminant for secondaries because they're not really contamination, but we typically, the standard for pH in our drinking water systems is 6.5 to 8 standard units. And that's what we look to put out the door. Generally, our Raritan system runs at about a neutral pH of about a 7. Things like iron and manganese are naturally occurring, but they can also potentially come from our source water or into our pipes from old sediments and older aging infrastructure. So a little bit, these standards aren't just made up, they're health-based risks set by the EPA. The US EPA sets the Safe Drinking Water Act, and it's, if you ever can't sleep at night, I recommend you take a look at that piece of legal document. But they set the rules and the standards across the country. The state from there is known as the primacy agency. They have the responsibility of enforcing and regulating drinking water systems within their state as per EPA guidelines. Now, the local DEPs, when I say primacy agency, just a fancy word for them being able to make a regulation more strict, but they are unable to make it less strict. So a really good example of that in New Jersey is arsenic. Across the country, the standard for arsenic is 10 parts per billion, but in New Jersey, it's 5 parts per billion. And this is based on exposure, cost to treat, and that's how they come up with these MCLs. And this is all the things that you could possibly test for in the permissible limits. So it's a lot, it really is. And we have to monitor at various locations throughout our systems. So a lot of this can be done at our point of entry. We also have a requirement to test our source water for certain things. And we also check things like like I said, coliforms out in the distribution system and the disinfection byproducts out in the distribution system. Same thing with lead and copper. These are distribution system parameters that test for. They're really not a concern leaving the plant, as they are typically a byproduct of what's going on in our distribution system. So in summary, our job is to protect public health. Earth is 70% water and only 1% is usable. So that really goes to show you how important it is to protect our water sources. Water supplies are becoming more scarce. We're blessed in the Northeast here, having pretty decent water available and easily attainable water supply, but out west, it's a very different story. If you've ever seen pictures of the Ogalla Aquifer and how that's been changing over the years, it's very scary. I think it's scarier than any horror movie I've ever seen. And as you know, the water industry is highly regulated by the EPA and the DEP. There's also the BPU, which is the Board of Public Utilities. A lot of people are under the impression that New Jersey American Water comes in and turns the rates up, and that's not true. We are not able to do that without approval from the BPU. So we're also heavily regulated by that entity as well. So that's all I have. So just again, thank you for having us, and looks like we're ready for some questions and answers, hopefully.
Great. Danielle, Cassandra, thank you very much. There are a couple questions in chat. I jotted down and probably about a half a dozen questions of my own. The real secrets, I organize these webinars so I can ask questions and I can learn. But the first question, so you have your treatment system. So, your clean water goes through your series of pipes. Then there's the service lines, which are customer owned. So how does someone know the water that you've cleaned and treated to standards, when they open up the faucet in their condo or house, that is actually still clean and drinkable?
So we test out in the distribution system all the time, and we assume that, and let me take a pause there, because when we say ownership over what's coming into your house, there are certain things that we don't have control over. If you have a treatment device that you're, maybe you like soft water and you want to strip all the hardness out, we don't have ownership over that. So you're at that point, you're your own little treatment plant for intents and purposes. The other thing we don't have control over is your hot water. You'll typically, and I'm sure this is a question that comes up a lot, is for our call center and our customer service people, is why is my water brown? And the first thing they're gonna ask you to do is go to a faucet and run the cold water and run the hot water. And if the cold water is not discolored and the hot water is discolored, you're looking at an internal plumbing issue, which unfortunately we can't help resolve, because the hot water, similar to your side of the service line, is under your ownership. But if you have any concerns about it, if you're experiencing discolored water issues, we would really appreciate it if you let us know. If we don't know they're going on, we can't do anything to help resolve it. So we ask that, you call our customer service or you self-report via the My Water portal and let us know what you're experiencing.
Great, thank you. Are there any plans to end fluoridation program? I know that has been a hot topic in the legislature over the years. Any thoughts about switching that out or going to something else, or just ending it?
That's a long answer. We did try to, like I said earlier, we work with hydrofluorosilicic acid, and I'll let Danielle speak to this because it is a TCPA chemical.
A DPCC. Yeah. It is a highly hazardous chemical. It's so I work on the discharge prevention portion of our chemical storage, and it's scary to have it. So we have to have all the regulations in place as far as secondary containment, and the tanks are all regulated and tested, but it is we're told we have to have it. So it's not something. It would be nice if it went away from my standpoint.
But
I don't know how else to say it.
There are health benefits, particularly, and this is why we've been unable to cease fluoridation, is through the American Dental Association. Once we've got that bit of treatment in, it's near impossible to take it out. And the lobbyists, they want it added. There is a health benefit to children for their teeth when it's added. It is safe to drink at lower levels. We generally run it at about a 0.7 part per million leaving the plant. The highest permissible level is for 2 parts per million when it's being added manually. If it's naturally occurring, it's 4 parts per million. Don't ask me how that rule came into effect, but it's a little bit of a different thing. But at lower levels, it is beneficial to tooth decay prevention and tooth development.
All right, great. Here's one that's got me. Is tertiary treatment on the horizon for New Jersey water suppliers? And if so, if reverse osmosis technology a leading candidate for tertiary treatment? Or
great question. I'll do my best to answer it. Reverse osmosis is very, very expensive. So utilizing it on a large scale is probably not a cost-effective option for water purveyors such as us. Tertiary treatment, for leaving the plant, it really just doesn't make sense, and it would jack the rates up quite a bit.
All right. If someone gets a report from a water company that lead is present in the water, should you drink it? And is there a way to get lead out of my home? So some of that, but
So with lead in drinking water, no level of lead is considered safe, but there are actions you can take to reduce your exposure. If you do have, so we go by something called an action level of 15 parts per billion through the state, and it doesn't mean that drinking water above 15 parts per billion is going to get you any issues, but well, just as I said, no level is technically safe, but 15 parts per billion is the limit at which a water system is required to take action and install corrosion control treatment, which we've been doing without being told to do that or having any lead exceedances in the first place. And we've been doing that since '94. But, you know, to reduce your exposure, and I do this every time. When I used to work in the laboratory, I actually used to analyze a lot of lead samples, and it really opened my eyes. We did a lot of private well tests and lead testing for our various customers throughout the state. We weren't serving New Jersey American Water, but you know, it's out there. The idea for lead, you know, to minimize your exposure, always let the water run before you take anything out of it. We're required to do what's called a first draw test, which is testing after a period of stagnation, minimum of 8 hours. So what you can do is take a flushed sample. If you're got a letter from us that says a first draw sample shows the presence of lead, we would recommend a flushed sample. So you can have assurance that as you let the water run, you know, that lead that's, you know, possibly there as a result of stagnation, that it can be flushed out before you fill up your cup or pot or whatever you're working with. And then to this day, I count to 30 pretty much every time I open my tap, and I know it hasn't been used in a while. So.
And just so I understand, so as the water sits in the pipes overnight, the lead, if you have lead pipes, that can leach into the water itself, which is why you want to let it run for a few seconds, minutes before taking it. And then you can have your pipes replaced if that is your source of lead.
Another source that people aren't typically aware of is fixtures or plumbing materials containing brass components. In 2014, they reduced the quantity of lead allowed in brass components. So if you have anything, you know, that was installed prior to 2014, that's also a potential source. If it's not the service line. Copper pipes with lead solder, those were really prevalent in plumbing fixtures from facilities built between 82 and 87. So those are, you know, another potential sources, that copper pipe with lead solder. The other thing you can do to reduce exposure is you can, you know, your sink has an aerator on it. It's good practice to clean that every so often and ensure that, because that can be a source of particulate lead, which, you know, would you want to, you know, clean that off every so often.
And then there are filters, I'm guessing you can install as well to get rid of it if you can't replace your pipes for some reason.
Definitely point of use filters are a great idea. You know, the person that I'm not sure who brought it up, but the RO question, there's a lot of under sink RO units that are very helpful in addition to passive filtration devices.
All right. And then another question. So the source of New Jersey American drinking water is the Raritan, the Millstone, and the DNR Canal. Is that correct?
Yes, primarily we pull off of the Raritan River. We also have the option, because we want to have resiliency and redundancy. So if ever there was an issue with the Raritan River, we would be able to keep our supply up with the Millstone and the DNR Canal. But typically our primary source is the Raritan.
Okay. And then someone asked, actually our development director, Jenny, asked the question I was going to ask. Does the quality of surface water affect how costly it is to treat? If we improve polluted stormwater runoff, does it make your job easier and less expensive?
Heck yes. And amen to that. You know, keeping that safe. We certainly, the dirtier the water, the more chemicals we're potentially having to use. So the cleaner that it is coming in is the better it is for everyone.
All right. Yeah, I was gonna sort of ask, I mean, it's important to protect the land around these water sources so that less pollution gets into them and it makes your job easier. Is that fair enough statement? I mean, that was the
Yes.
whole entire concept behind the Highlands Act. I know New York City has preserved a lot of land in the Catskills around their water supply to reduce the cost of treatment. I have a question. So you were testing and treating, I think you said 80 different contaminants as primary. Do you guys have to run a situation where you're treating for one chemical, which then makes another contaminant worse or makes the treatment for that contaminant less effective?
It's definitely a balance treatment wise to ensure that everything goes smoothly. A really great example of this is disinfection byproducts that I had touched on. We add chlorine to disinfect. However, when there's too much organic material in the source water or throughout our treatment, our sedimentation basins, we form these disinfection byproducts, which are those carcinogenic compounds. The trihalomethanes consist of chloroform, bromoform, dichlorobromomethane, and dibromochloromethane. Hopefully, just repeat that one, but it's close enough. But these are, this is why we add our preoxidants, like I touched on, ozone and potassium permanganate. This reduces the level of organic matter in our source water, in the water coming into our plant, so that we don't have, we have less of a demand for chlorine, and we're not forming those nasty compounds.
All right. And as standards get lower and lower or more protective, treatment is going to have to increase. So better we keep it out of our systems, the less expensive and less complications you all have.
Absolutely.
You mentioned, the railroad crossings and, the accident and contamination in Ohio. There was one just recently in Bucks County that spilled chemicals into a creek, and there was a lot of news with potential contamination of the Philadelphia drinking water. Is there anything you guys do or can do to sort of monitor upstream of intakes?
Yeah, there's actually the USGS has a really great network of sensors throughout. There's actually one about a couple miles up of our intakes that we monitor regularly. So we'd be aware of that, and just knowing, having those connections with the local OEMs, the Water Supply Authority, gives us the ability to be ready if there were a contamination event. We can employ things like additional treatment, and knowing what's coming down the pike is kind of important. We actually had a contamination event last year that turned out to be not a contamination event in our watershed. Up in the Morris County area, there was an overturned truck which spilled mulch dye into the watershed. So we were alerted. I'm not sure if anyone had heard about that, but we were alerted by the Water Supply Authority and imparted a hazy cloudiness to the water. So we were able, and luckily, because we have such close ties with the Water Supply Authority, we were able to kind of get ahead of it. We had about 48 hours to react till it reached our intakes. So we, once we identified what was causing that cloudy haziness, we were able to contact the manufacturer, found out that it wasn't hazardous to human health. We also are able to, we got a sample, and we were able to do something we call a jar test, where we do a very small scale version of our treatment process to see what it's going to look like as we treat it. So these are some of the things. We also have the ability to add powder activated carbon. This is a constituent that can really take care of a lot of things for us. Volatile organic compounds, things like oil and grease. It's effective on that should the need ever arise. Fingers crossed, and this is what keeps me up at night, is getting that phone call that something's going on. But we're prepared. We're in constant communication, and we have the ability to treat if we need to.
Yeah, that's good to know. And in fact, if I recall correctly, last year you did have some cause for concern, not from artificial chemicals, but from a harmful algal bloom in the millstone. So that was unique. I don't know that we normally get harmful algal blooms, which is a cyanobacteria, which creates neurological toxins and has a whole slew of health problems in the millstone last year, just above Carnegie Lake, or just below Carnegie Lake to be accurate.
Yeah, last summer was rough from a water purveyor perspective. We saw that Millstone River turn pea green. And so threat from a harmful algal bloom is twofold for us. The first one that you mentioned is the cyanotoxins, cyanobacteria, and the toxins they produce. We actually have in-house capabilities to analyze for things like microcystin, anatoxin A, and cylindrospermopsin. Those are kind of the big three cyanotoxins that exist out there. So I think we were monitoring pretty much every single day for these, both in our source waters and in our finished water, to ensure that we were meeting standards. So the EPA it's not a regulated contaminant, but it does have a health advisory level of 0.3 parts per billion for microcystin. And that's what got everyone sick in Lake Erie a number of years ago. But yeah, we also monitored the source water for nutrient loading. And we had kind of the environmental conditions were just right last year. We had very low flows, lack of rain, and a lot of nutrients being dumped into the watershed, which is why protecting the watershed is so important.
Yeah. All right. And remember, people, you can still put in some questions. Here is one more of a customer service question. So if someone calls customer service about an issue, brown water, are they going to be connected to someone in their area or someone across the country? And the people did not provide information about the local geography. So how do you guys set up your customer service, and how can people get the right answers?
So we're set up, we have a call center that kind of is a filter, so to speak, before it'll get to a local representative. So if you're not, that's who you have to get through first, and they'll go through their series of questions. I would say continue calling or try the self-serve portal if you're not getting to the right people. We try our best to give a Amazon-like experience for our customers, but being a big company, there are some things that we can definitely improve upon. If we're not doing a great job at something, we want to know about it. So eventually it will get to the right person, and typically it does. And I truly apologize if anyone has had difficulty getting to the right local people.
I appreciate that. I'll give a couple more minutes for anyone to put any questions, and I'll ask another one. Again, I do these so I can get answers. Microplastics. We're reading more and more and more about the impacts of microplastics, how prevalent they are. Is that something American Water is testing for? Can you remove it? As there technologies coming down the pike to deal with it?
I can't speak to that. That's I think more of an engineering question, treatment wise. At this point, it's not something that's a hotbed topic with our regulators. They're very hyper focused on PFAS right now.
Mm-hmm.
And PFAS lead 1,4-dioxane, that's where the heavy focus is right now. And not to say that microplastics aren't important, but given the prevalence of the other contaminants being a little bit more closer to home, that's kind of where our focus lies right now.
All right, fair enough. Yeah, and New Jersey has had one of the strongest standards in the country for these forever chemicals, and then EPA just recently proposed an even lower standard. that is, out for comment now and probably will go into effect in about a year. So all of our drinking water systems will have to start to gear up to start addressing those chemicals. I'll give a plug. We will be doing a 2-part Technical Friday series. These are geared for environmental advocates, attorneys, planners, engineers, scientists, people really, into these issues on the forever chemicals. The first part will be in May on the actual chemistry of it and regulation. And then the second part in September is how do we get rid of it from a drinking water perspective? How do we remediate our environment once it's there? So that's coming. Keep your eyes out if you're interested. All right. I think that is all the questions we have. So with that, Danielle, Cassandra, thank you very much for giving your time and providing all this great information. I learned a lot, which is the whole goal of this. For everyone who tuned in today, thank you very much for giving your Thursday or Wednesday evening to us and taking away. Hopefully you got something out of this. And again, thank you, and everyone have a good evening.